Transfer project. Oh boy. What you'll need for this project. Neodymium magnets, we got those at Home Depot for $3. Or $3 actually. You'll need AA battery. Some copper wire, which, sorry I've already used up, well, maybe I've got something over here. Nah, don't have much, don't have really anything. I'll go ahead and put this out. Now, you take the magnets, and you might want to use neodymium magnets because they're strong earth magnets and they work a lot better than ceramic magnets. And it's better you use AA. So you take the neodymium magnets, put them at the bottom of the battery. After doing that, take your wire, bend it into any shape you want. It works best if the shape has edges that are parallel to the battery itself. And when I put this on here, it's going to start spinning. Oh, before I forget, you need to make an indent there on the tip of the battery if you want the copper wire to stay on. Here's a demonstration. Oh, looks like we don't have good contact. Oh, there we go. Now, as the longer it stays on, the copper wire stays on, the faster it's going to go. See, that's why you want the indent, because that will fly off of the middle faster if you don't. Anyways, so the magnet makes magnetic poles, which those poles, when electricity runs through them, fell off, starts switching the poles around, making the copper wire spin. Let's see. You can make different shapes with your copper wire. Let's go ahead and stop this one, and be careful when you're touching the copper wire after it's been spinning, because this right here will be hot because of the electric output. And you
mentioned it's best to use a AA battery. Did you try using any other types of batteries?
Yes, I tried using bigger battery, a C-cell battery, and that didn't work out too well.
What did you observe when you used the C-cell battery?
I could not get good connection.
Is C-cell the only size you tried besides the AA?
I tried AAA, but it was hard because of how short it was.
Okay. So you said you had a hard time getting a good connection with the
C-cell
batteries?
Yes,
and why is that?
That's because whenever you take the C-cell batteries, let's see if I can find it. Oh, this is actually D-cell, sorry. D-cell battery. Take a D-cell battery, it's hard to get this to wrap around. And it gets too much connection. If it gets too much connection, it's going to cause friction, or it's going to, look, it's bending. It's not going to, needs to be loose enough that it can, sorry, I'm at a loss for words here. It needs to be loose enough that it can move around, but it needs to be tight enough that it won't try to fall off too much. If it was too loose, it wouldn't make contact at all, or it would hit the ground and cause friction and drag. Now, you don't want to get too much connection, because too much connection onto the magnet means that it'll cause friction and keep it from spinning. Now, you can try, like I said before, you can try this with different shapes. Some shapes works better than others. This shape used to be the best, but for some reason it doesn't want to work too well now.
Could it have something to do with how wide the bottom portion is?
I don't think so, because what it would do is it would switch to right here to an angle like this and spin around doing that. And I haven't seen it try. Well, I've seen it try, but it keeps going off. It keeps trying to fly off, or it keeps flying off rather.
Is
I
it because
don't-
is it because the bottom is too wide, or is that because maybe the weights are uneven, or
I think it has to do with this piece right here, and yes, the weight is uneven. I'm looking at this. I'm having this tilt forward and tilt to that, and this smaller one when it should be tilting back towards this. Let's see if I can fix that. See if it works. Maybe. Oh, looks like we might be getting something. Oh, it flies off again. Okay, I don't know what the problem with that one is too much. Here's another one. It's a little, this one's as unstable as the other one. As you can see, it goes all over the place.
why do you think it's unstable?
It's unbalanced. Right here and here make it unbalanced, especially since there's more weight on the back side because of these copper wires right here, or the copper wire right there.
So you need your wire to be balanced
Yes,
in
ma'am.
weight.
Yes, ma'am. Although it does stay on, it goes from being fast to being slow because it shifts between being balanced on the battery. Now,
It looks like it has a lot of friction in it too.
yes, because these right here clamp around those. I've tried making them loose, but if I make them looser than what they are, they will fly. It will make the copper wire fly off immediately. Something I've learned or seen is when you take the battery, switch it out around to the positive side of the battery, it changes which way the copper wire spins.
So what direction was it spinning before?
It was spinning, clockwise, I believe. I believe it was spinning clockwise. And now it's spinning counterclockwise. Something else, because I don't have that indent right in here, it's going into the groove of the negative side of the battery, which is causing drag. It's keeping it from spinning too much. And it's also unbalancing it. Also learned different shapes. If you take away the magnet, this shape will slow down. Whoop. Did I take one too many magnets away? Nope. See, there we go. That shape will slow down. But a different shape, like this one, will stay relatively the same if it has good connection. Oh, see, that one sped up. But that one sped up instead of slowing down. So different shapes will cause different reactions. Any other questions?
What's special about the type of magnet that you are using?
The neodymium magnets are strong magnets. They help. Let's see. I'm trying to think of the words. They make the poles stand out more. They make the poles stronger. And I don't believe that you can just take copper wire with a magnet and be able to pull it. So the magnet with the battery pushing electricity through it will capture. I think I'm confusing myself.
Well, we were talking about the magnet. Did you mention about how fragile the magnets are?
No, not yet, actually. The magnets are brittle. Very brittle. You can't just let them clack together because that ends up breaking them. I've already broken one set on accident, but we think it might have already been a little bit chipped because this set seems stronger than the last set.
When you were using the magnets that were possibly already cracked, did you notice a difference in the performance between that magnet and these magnets?
Yes, the magnets that we suspected were already cracked, they seem to work a little less. They didn't seem to be as strong.
So
these
the
seem to
items didn't move as fast?
they didn't move as fast. The taking apart and putting together was easier than with these. Look, I have to struggle. No. And definitely the magnetic pull is stronger. So with these magnets, you have to slide together and slide apart. Any other questions? Okay.
Oh, what kind of uses do these have in life?
Entertainment. I haven't seen anything other than entertainment yet.
So you don't know how we could possibly apply this in life? Maybe in the future or today?
Not really. Maybe there was something I saw where a guy had taken neodymium magnets, put one on this end, and put another on the opposite end. Oh. But instead of having these attract, he had them oppose each other so that whenever it connected with the copper wire, they would push back, making it go through a copper coil really fast. And we could probably use that to make items. Let's see, to move items from one place to another fast. Like in the banks, you see those tubes that have air in them that push the. I don't know what the cylinders are. The plastic cylinders that you put stuff in.
The money cylinders.
The money cylinders, thank you. Maybe if we could have something similar, maybe we can make something similar to that out of a copper coil and the batteries. Although that seems like it would be more expensive and consume more of the Earth's materials. It'll consume the Earth's materials faster. So it might not be too much of a good idea. But I've seen little people, they call it trains. So maybe we can make an actual train out of that. But we'd have to find a way to create a brake. Is there anything else? That's all. Okay guys, this was my science experiment. Hope you liked it. Let's see how the teachers like it.